We have looked at addition, subtraction, multiplication, factorization of expressions. Now let's look at rational expressions. And then we will look at simplifying the rational expressions. Rational expressions are of the type algebraic expression divided by algebraic expression. For example, x square plus x cube is an algebraic expression divided by x cube plus 2x square is also an algebraic expression. Now, remember, whenever we are talking of division, the denominator cannot be 0. But for the moment, we will ignore that because we will be focusing on simplifying the rational expressions. A rational expression is the quotient of two algebraic expressions. To simplify a rational expression, we simplify the numerator and denominator separately, factorize them whenever possible, and cancel common factors. Okay, so let's look at some examples. We have 2x to the power of 5 divided by 3x to the power of 0. Now x to the power of 0 is 1. So we have 2x to the power of 5 by 3. So that is our simplest form in which this can be written. Because 2 and 3 cannot be cancelled in any way. Okay. 6x to the power of 4 divided by 3x cubed. Now here we can expand x to the power of 4 and x to the power of 3. So we have 3 times 2 times x times x times x times x. So 6 has been factored and x to the power of 4 has been written in the expanded form. Divided by 3 times x times x times x. Now here factors which are common to both can be cancelled. So 3 and 3 gets cancelled. 3x's in the numerator and 3x's in the denominator cancel out. So what we are left with is 2x to the power of 1, which is equal to 2x. So 2x is the simplest form in which we can write this expression, rational expression. Or if you noticed, we can subtract the exponents directly. So we could have written it as x to the power of 4 by 3, x to the power of 3 is equal to 3 and 6. We can cancel to get to x to the power of 4 minus 3, which is equal to 2x. Third one, 2x to the power of 0 plus 3x cubed divided by 2x to the power of 0. So here x to the power of 0 is 1. So we get 2 plus 3x cubed divided by 2. Now, whenever we have a monomial in the denominator, in the numerator we have a polynomial which is not a monomial. We can split the rational expression into multiple fractions or multiple rational expressions. 2 by 2 plus 3x cubed by 2. So we can split it into two fractions. So 2 and 2 cancel, leaving 1 plus 3x cubed by 2. So this is the simplest form. A fourth one, x square minus 2x cubed divided by 3x square. So let's simplify the or factorize the numerator. We get x square is common, so x square times 1 minus 2x divided by 3x square. Now in the numerator and the denominator we have x square as common factor. So we can cancel them. And we are left with 1 minus 2x by 3, which as we saw in the previous example, we can split it into 1 by 3 minus 2x by 3. Of course, we can write it in this way also and in this way as well. So in all this, you might have noticed that only common factors can be cancelled. A factor can be cancelled only when it appears in both the numerator and denominator. So in general, when we were looking at multiplication of expressions, a x to the power of m times b to the power of x to the power of n. B times x to the power of n is equal to the coefficients multiply, so a times b, and when we are multiplying the variables, we just add the exponents, that is x to the power of m plus n. In case of division, as we saw here, the coefficients divide a divided by b times x to the power of the exponents get subtracted, m minus n. As I mentioned before, when we are dividing, the denominator cannot be 0. So b is not equal to 0. Now, when the denominator is a monomial, we can divide each term in the numerator separately, which is what we have done in this example, third example, and the fourth example. So in the next session, we will look at simplifying rational expressions where the denominator is a binomial. That's it for now as far as simplifying rational expressions with monomial denominator is concerned. Bye.